let's go over the quiz you took on Friday. Now remember, this was a calculator permitted. So if you're asked about whether a function is increasing or decreasing horizontal tangent, you're thinking about the derivative. So if the derivative is positive, you choose increasing. Derivative is negative, decreasing. If the derivative is 0, you'd choose this. Now I don't happen to have one of our graphing calculators with me, but I do have Desmos, and I've already put in my function evaluated at pi over 2. And it tells me that it's undefined. So what that means is I'm like dividing by 0 or something like that. That's what undefined usually means. So that means it's not positive or negative or 0, but I don't really know what's going on. If it's undefined, we're going to have to dig in deeper. That usually means that there might be a sharp turn because the derivative is undefined there. It could be that there's a hole in the graph. I don't know. So we can't make any conclusions. Now on the next one, it says, is the derivative, so let's make sure this is the graph of f of x, is the derivative 0 when x is 3? So I'm going to come over here, and at 3, that's a sharp turn. That's not the same as the derivative being 0, because it's different from the left and the right, so that is not an option. What about the derivative at 2.5? Is it greater than 0? So 2.5 is right here, and it does look like my slope is positive, so that's good. Between -4 and 5, there are 3 values of x at which f of x is not differentiable. Okay, so starting with -4, here's 1. Oh, here's 1, and here's 1. There are 3. So it's 2 and 3 only. Sorry about this. I'm trying to do this on the couch. All right, so we're finding the derivative of h when x is 7. Now we have a quotient here, so we're going to be applying quotient rule. It's going to be the derivative of the numerator at 7 times the denominator evaluated at 7 minus the derivative of the denominator at 7 times the numerator evaluated at 7, all divided by the denominator evaluated at 7 squared. So we've got all this information given to us, we've just got to plug it in. F prime of 7 is 14. G of 7 is 1 minus the derivative of g at 7 is 1/7 times f of 7, which is 0, divided by g of 7, which was 1, squared. Well, this gives me 0, and so I have 14 times 1 divided by 1, that gives me 14. The next one is showing the relationship between temperature and time, and it asks what the derivative at 6 represents. Derivative is your slope, it's your rate of change. H of 6 would be the temperature after 6 hours. So notice that they have, this one's talking about the temperature, this one's talking about the temperature, so those are not my options. B and D are both talking about rate. Now rate of change, your slope, it's change in y over the change in x. It's the change in temperature divided by the change in time. So both of them talk about the rate, but only one says it's degrees per hour. That's a rate of change. So units are very important. They change the meaning. Okay. The next one, we have h of x presented here, and we're asked what is the value of the derivative of the inverse. So the derivative of the inverse is going to be 1 over the derivative of the inverse at that value. So I need to find the inverse at 6. Inverse at 6. Well, that's going to be the x value that gives me 6 on the original graph. So here's 6 when y is 6, x is 0. So that's 0. So now I'm going to plug in 0 for this, and I'm going to get 1 over h prime of 0. So I need to find the slope of the tangent line when x is 0. So here's 0. If I drew in a tangent line, it's about like this. I'm kind of guesstimating. It looks like it's about 1/2. So I've got 1 over 1/2, which is going to be 2. It's the reciprocal of 1/2. The last one is product rule. The derivative of the first times the second plus the first just like it is times the derivative of the second. And well, that's just e to the x times the derivative of the exponent, which is 1. Now I look down and none of those match my options. So they both have an x and they both have an e to the x. I'm going to factor those both out. When I factor it out from the first term, I have 2 left. From the last term, I have 1x. Oh, and that's the same as x plus 2. Next one. The function is pictured at the right of which of the following values is f defined and continuous, but not differentiable. All right, so we'll check each of them. At 2, it's defined but not continuous. 3, defined, continuous, but not differentiable, because it's that sharp turn. 5 is defined, it's continuous, and I could find the derivative there. Actually, the derivative there is 0. It's smooth. So it is differentiable. So the only place that meets all 3 of those conditions is 2. Now to the free response. So we have a table with a lot of values. We're going to have to go back and forth and look at that a lot. And the first thing I see is that it says we want to approximate f prime at 1.5. So 1.5 lies between 1 and 2. So I'm estimating the slope. So I'm going to find the slope. I'm going to think slope of the secant line. I've got to find the slope. So I'm going to do that the derivative at 1.5 is approximately the same as if I took f of 2 minus f of 1, y2 minus y1, over the change in x. So f of 2 is 5, f of 1 is 3, over 2 minus 1, which is 1, and I get 2. Then it asked me if this would be a good approximation, and there's so many ways to explain that. I would actually say it is a good approximation because I used 2 points that were very, very close to 1.5. Using the points when x is 1 and x is, or 2 are very, very close to 1.5, so it makes it a good approximation. I'm not going to write all that out. There's a lot of ways you could have worded that. All right, so b of x equals the square root of g of x. So that's really g of x to the 1/2. And we're asked about the equation of the tangent line when x is 1. Okay, equation of the tangent line. I need to find the derivative. So b prime of x is going to be 1/2 g of x to the negative 1/2. But then there's kind of a chain rule here. G is a function of x, and it's on the inside, so I need to multiply by the derivative of g. So, negative 1/2 in the exponent really means 1 over the square root. So this is 1 over, I'll just put the 2 with it, square root of, and we can go ahead and plug in 1. That doesn't hurt anybody. So square root of g of 1 times g prime of 1. So g of 1 and g prime of 1. I need to know both of those. G of 1 is 3 and g prime is negative 3. So g of 1 is 3. Whoops, hold on. I hope I didn't lose all of that. G of 1 was 3, so this is 1 over 2 times 3, times the derivative, which was, oops, I forgot the square root. G of 1 was inside the square root, negative 3. So this is negative 3 over 2 root 3. That's the slope of the tangent line. Now all I need is a point. And let's remember, our point is going to be on b of 1. So going back to b, which is the square root of g of 1. Well, g of 1 was 3, so this is the square root of 3. So my point is 1 comma square root of 3. And I just write the equation. On the next one, I've got a crazy looking function. And it asks me to find a prime. We can do this. There's a product. So I'm going to start with product rule. Derivative of the first times the second plus the first just like it started. Now the derivative of a natural log is 1 over the argument times the derivative of that argument. Now I'm going to plug in 2. 2 times 2 is 4. Natural log of f of 2 plus 2 squared is 4 times 1 over f of 2 times f prime of 2. Well, if I look back at my table, f of 2 is 5 and f prime of 2 is 3. So this is going to be 4 times natural log of 5 plus 4 times 1 over 5 times 3. Molly, this is positive. This is positive. A prime of 2 is, if a prime of 2 is positive, then a of x is increasing at x equals 2. Ooh, the last one has the derivative of an inverse. Now be careful of what they're asking for. The equation of normal, that's perpendicular to the graph of the inverse. So when we find the derivative of the inverse, we'll find our slope of the tangent line. So the derivative of an inverse is going to be 1 over the derivative of the inverse. Oh, I guess I could go ahead and plug in the 3. Doesn't hurt anything. 3, plug in the 3. So when I go back to my table, the inverse at 3 will be whatever gives me my original to be 3. And that's 1. So I get 1 over g prime of 1. And from the table, that's negative 3. So 1 over negative 3. That would be the slope of the tangent line to inverse of g. So normal slope is the negative reciprocal. Now all I need is the point. I need the point when x is 3 on the inverse. My camera keeps bugging out on me. Sorry about that. So you end up with y minus 1 equals the slope times x minus 3. I hope this comes together. My camera kept dying on me in the middle of this, and it doesn't help that I'm not feeling good. So hopefully that all made sense. Don't forget to do the practice problems that I showed you that were in the book, and the key is on Google Classroom. Send me questions on Google Classroom if you'd like. I could work out a problem and take a picture of it or something like that. Sorry, I can't be there today.